Hey everyone, welcome back to the channel. I'm currently at my desk here doing some more CAD CAM stuff. We got the VF2 running in the background, doing those aerospace titanium parts. So there's a lot of content for that in this video here. You'll get to see that. Some little bit of tweaking to the fixture, so you'll get to see that as well. Also the lathe, the soft jaws are in here too. We're going to do some cutting on the titanium parts in there to get them op one done. We had to clean up the parts a little bit to get them to fit inside of this fixture, so we can finish making those parts. So you get to see a lot of that. I also talk about the tooling that's in for the lathe, and bring you in with a little microscope, and you get to see what I'm talking about, or how it wears down the inserts for the lathe. Really cool video. I talk about tooling I use as well for doing this, and obviously for the lathe. So you get to see some of that. Some new tool holder we got in. I'm excited to try that for the C10 dashboards. We're going to do those out of aluminum on the VF5. So real excited, real pumped to get this content out to you guys. Again, please like, comment, share the video. Please consider subscribing. If you have any questions, drop them down in the comment section. I get to every single question. Unless it's just a stupid question, I'm not going to respond to it. So hopefully you guys enjoy it, and let's get to it. All right, so we're over here on the lathe, and we have our soft jaws installed. And remember back in the previous video where we had made the soft jaws for the lathe to hold that titanium part, to do some rework, and bring some of the tolerances in. Now, I'm still within, on the ID bore, actually a good tolerance. It actually turns out my mistake. The OD is where I'm having the issue. And there were some, I actually thought there were more ID concerns with the tooling than there were OD. But I actually have one of the inserts that we swapped out, and I'll show you guys that in a little bit. But I'm going to swing the camera around, and I'm going to show you what I have here set up, and then we'll go over to the table, and I'll show you what I'm working with on tolerances and where some of the parts are at now to get them prepped to go into the fourth axis. And again, if we go back to another video on the fourth axis fixturing, it's a tips and tricks video, you'll see the fixture that I have. And I also might swing the camera over to the VF2 that's being currently run right now to do the final operation on those titanium parts. You can hear the noise. And if you do hear the chatter, yes, there's a little bit of chatter. It is a roughing operation, technically a roughing operation. And with that, we're running 7 times diameter stick out. So you're gonna have that to be able to get around inside and the outside of the part. So I'll swing the camera around and we'll take a look at what we're working on right now. All right, so we have one of the parts in there. Now you'll notice I did modify the jaw a little bit for the boring bar to be able to get inside to do some of those critical dimensions. And if you recall from that video, I did mention, I did have modeled that the soft jaw itself, I wanted it to be tapered to match this profile. It actually, not that it wouldn't grab it, is that I couldn't get the tooling in there to actually put the bore in to grab this part here. This is 794 thou, I think this diameter is. This being one of the crucial diameters, and here there's just a little bit of raw stock left from the 1.5 inch diameter titanium raw stock. So right there we want to grab that as well. So that's what that does. So you'll see I have it set up in here. And I actually wound up going back. I wound up going back and rough machining the soft jaws in on the VF5, and then just slowly kind of walking them in to where I needed them to be. They might look a little rough in there, but that part doesn't really matter. Down in there, it's just really hard to see, but that one final bore, so that one final bore all the way down in there is critical, and then the first 250 thou is critical from the face of the jaw back to there. So you see that. Everything else I can really care less about. Alright, so then we put one in there, and then we go ahead and send the jaw down. Right now we're locked in pretty good. We got our WNMG, pretty sure it's a VNMG insert. And I will show you what the titanium over time actually does to the insert. But you'll see here, we have it in, and all we're doing is just kind of running it down, just ever so slightly. We're about 12 thou heavy on the OD. Not on all the parts. I think right now we're about 15 of them Not all of them are that big. I think we have probably 4 or 5 of them, or 15 thou. The rest of them are a couple thou, so I want to get them down because it is a tight tolerance on the fixture, which I want it to be, critical to the part being linear in it with its features. So this works really great. I'll actually spin the chuck up here so you guys can see. All right, so we got it spinning. Everything looks pretty good. And we're all set up to do it. I'm actually doing it manually. I have so little to do. And I've noticed I can get rid of some run out by kind of setting these in and out a little bit. It's just funny how it is. I kind of do it by eye. Again, there's plenty on the inside and enough on the ID and the OD for me to allow it to be out, let's say, a couple thou. Totally fine for what I have to do. I'm not too concerned about it. Let me bring you guys over to the table. All right, so we know we're familiar with these parts here. And again, we're trying to clean up this OD surface to fit into the fixture. So we're going to take care of that. And if you're wondering, I'm using these Sandvik. Let me see that. And TC. For the ID boring bar. And the OD is a Kennametal tool. Kennametal VNMG. What I was trying to explain, and I'm going to try to do this best I can. If you look on the screen, it's not necessarily a broken insert, it's just worn down. And you can see the angle on it. So all 4 sides of this are like that. But if you look, again, it's just worn down. It probably would be a nice, garbage insert for some steel or stainless. Well, maybe stainless, but it might be a great insert just to kind of rip through some stuff. They're kind of pricey. We have the speeds and feeds dialed pretty well for what we need. And we're getting a decent amount of life out of each insert. It's just that's how hard titanium is on there. So you'll see on these parts that the surface finish isn't terrible. I mean, it's totally acceptable for what our requirements are for the job. And, they're done. These have been getting banged around. I don't really care for these because they're going to get refinished. But you have to understand, again, the surface finish would look a whole lot like it would be terrible and non-compliant if this insert was chipped or broken, but they're not. All they are just worn down. So, well, at least what's nice about each insert is we have 4 sides we can utilize, and not too bad. I forgot how much they are. They are a Kennametal ALITIC, whatever it is. I forgot what it is. If you want to know what it is, drop a comment, and I will respond to that comment with the appropriate number. But again, doing this, now these were done as Op 1 in the lathe, and I'll kind of do a representation of that. So very similar how it is sitting in here now, except hard jaws were used to hold the raw stock, which each length of titanium was 4 feet. So then it would get pushed out from the bar feeder, set to a certain length, and machined just as you see it here. And then, of course, the cutoff tool there, paring tool, leaves that nub. And then what I actually do is, currently it's not a crazy high volume. Currently, it stops the machine and lets me op stop it, and I break it off. I have a parts catcher. I just don't really feel the need to do it for, at least for the first 50 parts for the first article inspection. So it's your AS9102B. That has to be done on every single one of these parts. So for now, that's how it is being done, and how I have it programmed not to cut all the way down. So it still leaves it, come over and just literally just break it right off and hit cycle start again, and it starts it all over again. So now again, we have it in the soft jaws to grab it, and you can use hard jaws, it really doesn't matter for this operation because we're grabbing still on raw stock. And again, I'm leaving about 40 thou remaining stock on here. So, and I'm doing it by hand, just kind of walking it in. I'm not doing that many, and they're coming out spot on. So let me bring the camera over so we can get a glimpse of what the VF2 is doing with the fourth axis. All right, we got a great shot of the fixture. Now, if you've seen the other video, the fixture was slightly different. I never had an issue with it being able to hold the part being rigid. The problem was, and I'll go grab it in a sec, but the problem was is that the ER50 collet, I used a pipe wrench to tighten it, and it still had enough force to allow it to slip. So what I wound up doing, if you recall, I had a spacer underneath the fourth axis. I have this really beef, I know, sorry, it's really hard to see. For a good reason, it keeps me out of trouble. But I have an ace support, a bearing ace support. I couldn't space that up because it's only so limited and I didn't want to. So I wound up lowering the entire fourth axis down to normal 6 inches above the center line of the fourth axis is 6 inches above the table. So let me grab that ER collet and I'll show you guys. So as I was saying before, with the ER50 collet, even this massive collet with full engagement of that fixture, it's still spun in the fixture. As I tighten this, you can see with a pipe wrench, it's still spun. So I had to kind of rethink that. But overall, the fixture itself is still the same. So here is our original fixture, and we definitely got a lot of use out of it. The reason why I scrapped it as well, there's actually nothing wrong with it. Well, technically not. I wound up over torquing a couple of these and tearing the threads out of it. But ultimately it worked fine. And like I was explaining to you before, as this sat in there, it didn't matter how hard I tightened it. The titanium is just so resistant to the tool pressure, it still acted as a lever and still spun this in there. So we were losing our A0 basically was kept moving on us. And we started noticing it in the parts, so we had to quickly reevaluate that. So again, there's nothing really wrong with this. It's on how it can hold the part. Held the part great. They never moved inside of here. We know that for a fact based on one of the operations. Not even a question. You could even see the bores where they just constantly stayed at a rigid state. It's just where this was not enough pressure for that. Could be a couple different reasons. Could be really soft on the material here. That's obviously a consideration. So what we wound up doing is making a plate, a large plate. I think I had it. You might have seen it in one of the videos. I wound up cutting it down. But I'll go over there and, sorry for jumping around, but it just kind of makes it easier. Well, hopefully it helps. I try to clean the window. It's not going to last long, so I'm going to talk fast. You can see the new face platter, okay? And then we have our A support there, bearing A support. Everything is linear, and then I decided to make it only 2. Not for any other reason that I didn't want to have a long stick out again. And now that there's nothing really protruding it out more like the ER collet 50 would have, pushing it out 3 3/4 of an inch away from the face platter. So I felt 2 was enough. It really doesn't matter. It also helps me with my checking the tooling and then changing the tooling out based on runtime. So we're kind of on the ragged edge with 4 tools because one of the tools with 4 parts, because one of the tools does a lot. The 3/8, 5 flute, or 6 flute does a lot of operations, roughing, boring, adapting deep down in the pocket. It actually goes down. That's why we need 7 times D. It goes down 2 inches, a little over 2 inches. Let's go back over here. Got a pretty good shot. Nothing. So now it's going to roll down. Now it's going to start doing a contour feature to finish off the top of the part. So getting back to how I held this on, that one plate has it was actually done in the Haas lathe, spun down to where we can then receive 2-inch end, right? So we spun the whole thing down to 2 inches. This is actually 2 1/8 stock. Spun the whole thing down and wound up doing a receiver pocket, 2-inch tight tolerance receiver pocket, but then put on the other side of the plate, the board of the 4th axis is 2 inches. So then on that adapter plate that's on the face of the 4th axis is a 2-inch by 1/4 inch long receiving pin, if you will, that goes to the board. That helps center that plate up. Then there's 3 holes drilled and tapped for 1/4-20s holding that current fixture from trying to turn. That was necessary. This is a great idea, a great concept idea, maybe for a couple parts, but eventually it started to rotate. You know, if we had to leave this in here, whatever the reason. Also, different material probably would have dictated that as well for this. But it's aluminum, it's cheap. We're still on the cheap end of doing this fixture, and Rev 2 on that fixture is working great. We have a lot of parts already run through Rev 2 of that fixture with 0 issues. So that's good. We got that resolved. Again, great idea, great concept. Just in reality, this could not hold the aluminum from spinning. So just imagine that. It's only so much as it would sit in here. Not sure if these aren't done yet. These still have to get opened up. But imagine that kind of sitting in there at that depth. And it's only removing 40 thou, but it's enough pressure on it to turn this, losing our A0. Alright, so I got the camera over here. I'm actually going to do a little hyperlapse of just me kind of manually doing it. It might seem like a huge pain in the ass, but it's not that many parts, and we've already created a different metric or cycle to be checking these with a better system. Yes, we can come over here manually and do that, which there will be an interval of us doing that, but at the same time, the program and the machine tolerance is so dialed in, it's just going to be a matter of just swapping these inserts out no matter what. So, you know, instead of us, you know, the time it takes to have to do this, it's not worth it for the next 200 parts. So, we'll do a little hyperlapse. You might, the door's not going to be totally closed. I am protected by this very thick door, but I will have it covering myself for safety. I will have safety glasses on. And then you'll see me kind of quickly get that done. All right, as you can see, we're done with that. Came out perfect, exactly on tolerance, not a half a thou more or less. So you can see the surface finish is pretty dang good. It's crazy good there. And you can see the ID. We haven't touched the ID because it's still good. Like I said, some of these were funny that way when it came to ID/OD stuff, but it came out great. Now we're ready to put it into the fixture. Not too bad. Really good surface finish. I'm sure when we put it on the machine to measure surface, it's going to be fine. Perfect. This is a good angle. If you can see, some of the stick out on that tooling is insane. And it really kind of threw us for a loop because we were getting information on speeds and feeds for titanium. Now, typically titanium is 175 surface foot a minute. I think we're running at about 185. And then there's different variables for certain tooling and step over. So you have to look at that. There's actually Helical Solutions tooling. Great stuff. Really great stuff. If you're wondering too, my tool touch-off stand that's straight in the middle here, I had to machine that down to 5 inches. So now I have, with my SPI height indicator, I have 6 inches. But as I have the camera pressed up here, you can start to see the parts come in. It's pretty solid. And again, that little bit of chatter, it's unfortunate, but the tooling's actually been holding out pretty well. It's a 3/8 ball end mill. The two you see on the kind of left center of the screen there is a 3/8 corner radius 5 flute, or 6 flute, I keep saying 5 flute, corner radius, and the ball end mill, the longer 1/4 inch ball end mill, which does some finishing work. And we just have enough stick out. Now the tool's meant for that. The reach of the tool is meant for that. And so it's just enough to get down all the way up inside of the part. I wish I could show it to you guys. I really don't want to risk it. But, you know, moving on. Now, if you're wondering what tooling I'm using, again, Helical Solutions. I'm a big fan of Helical Solutions. Let's be honest. The reason why is I can get a lot of their tooling where it's a relief shank. It makes such a difference, especially when you're coming down a wall in a pocket. You don't want to have any excess chip cutting, and it just destroys the inside of the part. I primarily get this brand tooling with a step, or an aluminum, steel. I don't care what it is. Well, I use most of this stuff here on the T+. I'm using T+ on titanium. It works fine. The surface foot is still the same. They do have A+. This is actually a ball end mill. 6 flute? I don't remember. This is not the right case, but this is an A+ cutter. They're all still about the same price. This is a high feed, which I actually used for quite a bit. I actually prefer not hearing the noise of this high feed over this 6 flute. And the only other thing I don't like is on the high feed, the corner radius, how do they call it? They said something funny. It's like, it's an estimated corner radius because of the design of the high feed end mill. It works great, it cuts, there's really no issue. The tool's not worn. Come on. I don't know. But they work. I wanted to grab, here's a worn out reduced shank 3/16 step. Reduced shank 3/16 corner radius 3 flute for aluminum. I think it's helical as well, yeah. Here's some of the part numbers. That's actually the high feed part number 1 there. And this is the 3/8 2 flute. Or 5, damn. Yeah, 6 flute. Corner radius, 20 corner radius. All right, this is this is a hydraulic tool holder. Now you have your standard ones, you know, your ER20 collet holders. They work great. I don't really have an issue with them. Mari tool, I've talked about them before. They have really nice stuff. I mean, for the price, it's really nice stuff. This is one of their hydraulic holders. And what's cool is I actually have a 1/2 inch hydraulic holder for the VF2. The only issue with the VF2 is, and I'm not going to get started in this video, but it's a BT, no difference. Taper's no different. A little shorter, a little longer pull stud than a cat. 40. But anyway, I got this for the VF5 since it's a Cat 40 umbrella, tool umbrella. What's really cool about this one is I didn't realize this, that they have these sleeved collets that can go in there. Now what they did tell me is it's, if you look it up, it's not meant for roughing. So you can't do, I wouldn't say, I do mediocre roughing on aluminum with mine, but it's not really meant for heavy duty roughing. But the total indicated run out is like nothing. You know, I think they advertise it as like 2/10, but I can't, if you put a tool in there, like if I put a 3/8 tool in there, I barely see anything on my Mitsutoi. So it's really good. Balanced pretty well. Nice, it's nice stuff. They're obviously more money. I think they're like 205 or something. I forgot what this one is. I just recalling what I paid for my my one for the VF2, the 1/2 inch. This is 3/4. And again, Mari Tool sent this to me, asked me to try it out. I'm actually really excited to try it out. It's not a paid thing. They just know I've been a loyal customer to them for a long time. I actually asked them to send me this. I wanted to try this out, and they were nice enough to send it and not charge me for it. So that's pretty cool. And they sent these collars here. Now, if you don't know, when the hydraulic uses, a hydraulic system, and there's a set screw here, and it's a 4mm. What you want to do is you tighten this. Once you put a tool in there, or a collet with a tool, you tighten this all the way down. You don't have to wrench it. You don't have to torque it. You don't have to, just a simple T-handle in there until it bottoms out and you're done. That's it. Not a whole lot of pressure. You don't want to be doing that when there's not a tool in there. It's not good for it. But yeah, I'm really excited to try this out. Thanks again to Frank over there and the guys at Mari Tool for sending it over. We're actually going to be doing a video coming up. We're going to be cutting the aluminum C10 dashes, the final operation, using this holder. Only because it's not a very well supported part, so we want to make sure we have every bit of advantage to it, and this is definitely going to help us out. So can't wait to try that. Got some other cool stuff in here, I guess. This is actually going to be used for boring and sleeving the LS block. That's coming up in a video. Got a couple others. These are all Sandviks. If you don't know, that's a BT and a CT, if you didn't know. A lot of the smaller machines are BT30. You could spin them a lot higher. And if you don't know, the RPM max, like the mass of this, they can only, Cat 40 can only spin a certain amount of RPM before the pull stud check balls start to spread away. And that's no good. That's why the HSK tooling is nice, because the check balls go from the inside, and the more RPM, the technically tighter the tool holder gets. So we got that coming up in another video. Again, shout out to Frank at Mari Tool. I'm excited to try that and see what results I get. I'm sure they're going to be great. And if you don't know, if you have a smaller tool, like this is an 1/8 inch ER collet, it's not necessarily the tool, it's just the collet, and they're not perfect. You see, I beat the shit out of them. I forgot what happened there, but the collets are cheap enough. So, you're going to have some indicated run out, and it's just based on, how this is sitting, if there's any debris in the way of it or anything, and you could check it with a dial indicator and see how you put the tool holder and the tooling into the spindle and you check it to see where the run out is. You're just going to get a little more indicated run out just because of the body of the holder. Nothing to do with the quality of the holder. It's just the name of the game. So, and of course you have your Weldon flat ones, your standard shank ones. I don't know. I have a couple buried in somewhere. I don't use them. All right, so I'm back over here on the lathe. I got to get some work done, but I really hope everybody enjoyed the video. Please like, comment, share the video. If you have any questions, drop them in the comments below. I answer them as best as I can. I usually answer most of them with some type of reply, the reasonable ones. Definitely please consider subscribing. That really helps me grow the channel. It really motivates me to put out more content. And definitely the comments. I really enjoy doing this stuff. I really kind of like bringing people in. Hopefully teaching you guys what to do, what not to do, or just something you guys like to watch. What kind of exciting things that happen here in the CNC shop. But again, please comment, like, share, subscribe. And I'll see you guys in the next video.